Without virtualization, there is no cloud computing. Second concept, which actually also plays a vital role in this, is distributed computing. And third thing, which is autonomic systems, and these means that your system should be able to work automatically, and they should be able to provide the services to the clients. For example, if you have 1 million population and they're using some systems, it should automatically handle that. The cloud should be able to do that. Grid technology is okay. I worked in grid technologies. I don't think so. It is part of this, but its distributed environment, the way the grid operated was, it somehow gives some features to cloud computing. Fourth thing is broadband networks. It is very important because without broadband, if you take broadband out, you don't have cloud computing anymore. The sixth thing is Web 2.0, which is now you are using web applications, you are using service-oriented architectures, you're also using free and open source softwares, you're using web application frameworks. The technology that actually advanced the cloud computing was browser as a platform, where you can use the browser to do anything you want. Now, there are two last things. Utility computing is okay. The last thing is service level agreements. Now, when you're doing the cloud computing, you must have a service level agreements with your customers, with clients. So you must see that how long generally they will be able to provide you with the services. Now, if you see the cloud computing or Amazon cloud computing or you see Azure cloud computing, you will see the service level agreements are 99.9% or 99.7%. Then the system will be available to you. Okay. Now, one of the most important factor in cloud computing is the service ownership of responsibility structure in cloud computing. This is sometimes confuses the IT people, and it works. And because the responsibility shifts between the cloud user and the cloud service provider, especially if you're using SaaS, software as a service, generally data and application, for example, authentication, is jointly owned and by the user and the cloud service provider. When you work on the platform as a service, your data is user data because he's programming. Rest is application and security is also joint. Rest is all cloud service provider. CSP is cloud service provider. Similarly, when you go to infrastructure as a service, users have more responsibility and there is more joint responsibility between security, storage, network. Physical layer always stays with the service provider. Okay, in IaaS, in PaaS, in SaaS. So with this, what happens is that the security shifts between the service provider and the cloud server and the cloud user. This is a small architecture for Azure Cloud. And I'll explain you a little bit on this. Now, you will have similar architectures all across any cloud platform, but this is because they use similar infrastructure. For example, there's a deployment A, which is tier 1, deployment B, tier 2, and deployment C, which is tier 3. In a virtual environment, the client will connect through port 443. You don't allow HTTP, you only allow HTTPS. And it will connect to deployment A, deployment B, and deployment C. Now, with each deployment, you see there are VMs running, Between the VMs, there is a firewall. And between the VMs and the client, there is a firewall which is protecting the security of the system. It also has a load balancer from where the client connects. So if you have 1 billion, 1 million or 10 million associated connections, your load balancer is able to handle that and it's automatically done. So you, from the cloud computing perspective, you don't have to worry about the load balancer, or you don't have to worry about how many people are actually working on your system. For example, Facebook has more than, I don't know how many, maybe 10 million or 100 million or maybe 1 billion subscribers. So they are able to access that. If you see the cloud environment, if you want to see the difference between cloud is you see Netflix running smoothly and you see Amazon Prime running a little bit slower than Netflix. Netflix has more better infrastructure. It's more beautifully done. Okay. Similarly, the corporate environment can connect through the VPNs to any of the deployment A, B, or C. They can directly connect. They have the storage. They have everything. And with every control that path from client to the environment, these firewall and access control this. So it's on you to control the access to the servers, not anyone else. Okay. And for the private network, if you see the right side, which is customer two, it's an isolated private network. So it's a private, so they can only access their environment. Okay. Now, the cloud architecture is based on, cloud computing is based on design, enterprise architecture, risk assessment, and programming. If you see the dashboard or AWS, it has an architecture already inbuilt, but risk assessment and any programming, for example, you want to do DevOps, you want to run a script, it's all up to you. So risk assessment is the vital part of any cloud environment. Okay. So enterprise design actually comes from you, what you want to design, and cloud will provide you all the information. The risk assessment is important because it goes with the legal and assurance and accounting requirement. Any questions so far? Class is so good. I'm amazed. Oh, come on. You can see I can't log in. That's amazing. Yeah. Okay. This is the actual infrastructure of cloud computing. I just want to give you an overview, nothing more than that, okay? You want to have to run any services, you can run the services and it's much easier to do that. For example, if you want to run a virtual machine, you type EC, oh, which is virtual service in the cloud, and you can run it over here. You will learn this in Amazon dashboard or Amazon courses. So I just want to give you overview, and then you can, for example, this is my name. You can go to the billing and cost, and you can see how much bill I'm getting, right? So in the first lecture in Amazon, or 2 or 3 lectures, you will find that they will tell you how to do the MFA, which is very important. Also, they will tell you about how to actually create a network so that your network is faster than normal. Okay. Any questions so far?
So far, so good, I think.
That's good. I'm done.
Cheers.
So, oh, Yong, you came back? You said you're going? Okay. So you need to go through your course, which is on AWS, and that will be great. Okay. Go through the AWS course and let me know if you have any questions. Go one by one, and it will be great. Module 1, module 2, modules. You will learn a lot. And if you have any questions, I want to tell you about this cloud definition. Reason is, when NIST was creating the cloud definition, the person was Peter Mell. And at that time, he was I worked with him, and I exactly know how this actually definition came up with. Okay. So if you have any questions, you're most welcome to ask me, because I knew how NIST came up with this definition, and I exactly explained to you everything. Okay. So I want you to go through your course, which is AWS, and you should finish it. And if you have any questions, we'll join next week.
Sounds good, Rizwan.
Okay. Kyril, I will put your attendance, don't worry, okay? If somebody is absent, just email me, okay, so that I can put the attendance. Okay, guys. Yeah, who's there? Oh, thank you. See you next time, okay? Next week.
Thanks, Rizwan. Bye.
Thank you. Bye. Cheers.